Exceedance and TFI Marine have come together to produce a 1 kilowatt power system for offshore aquaculture. The system is called the Gator, and the problem that it's solving is it's providing offshore power for remote aquaculture plants out at sea. The energy is actually there in the form of the waves, and we help convert it into energy for use on board the platform. One of the challenges in the world is providing enough protein for our diets, and one way to do that is to have much more offshore aquaculture, and you can see lots of countries are trying to do that, but the challenge to do that is getting access to the energy in those remote locations. Offshore aquaculture is going to be an important industry, not only for the provision of food, but also for the provision of jobs. One example would be in the west coast of Ireland, where we can create a lot more jobs in rural communities. Exceedance and TFI Marine are actually going to take a device that's been under test in a laboratory. We're going to take it into the ocean and do a first prototype. The funding from the Marine Institute is critical for our success. It's a follow-on project from Eureka Energy Scotland, and we're really looking forward to getting into it in the next 18 months.
The view from subsea micropiles is current methods in offshore construction for foundation anchors are very costly and have huge environmental impacts. We are actually adapting a solution that was developed on land 70 years ago, which was borrowing cues from nature in the way that plants and trees use their root structures to mobilize a big soil mass to create a big solid anchor. It's a much more elegant way to do a big construction job. The biggest beneficiaries of this better method of construction will be the offshore renewable industry. Anchors and foundations are an enormously large part of their capital cost, and this will help them access new resources by reducing the cost of construction. The funding from Marine Institute is critically important to subsea micropiles. It provides a very useful focal point for our partners and our clients to advance this technology for commercial applications. From the perspective of subsea micropiles, this project is critically important to advance the technology for commercial applications.
And my partners in the project are Solar Marine Energy Limited. We're going to design a floating platform with solar photovoltaic panels for generating solar electricity, which will be used with electrolysis to produce hydrogen offshore. One of the problems with energy generation at the moment, particularly in the marine sector, is that it's carbon intensive. This represents a local solution which can be deployed locally near the point of demand for producing zero carbon, zero emissions energy, which can be used as clean fuel for marine transport. It can be used as a vector for energy storage, and it can also help integrate renewable energy into existing energy systems. So anybody who's involved in energy use in the marine sector, it'll also potentially benefit renewable energy generators who are looking at new ways to store and transport electricity in the form of hydrogen energy storage. Front-end engineering design project for hydrogen systems, the project that UCC and Solar Marine Energy are collaborating on. It's important because it represents a way to use currently disused areas of water in order to generate a clean source of hydrogen, one that doesn't rely on fossil fuels for generation. So it's a zero carbon solution for hydrogen production. Without the Marine Institute's funding, UCC and Solar Marine Energy wouldn't have come together in order to perform this work, and it enables us to work together to put in place the critical engineering design phase. That wouldn't have been possible without the Marine Institute's funding.
Our project, Wave 2.0, is a wave-powered desalination plant which addresses the issue of water shortages amongst developing communities. The beneficiaries of the Wave 2.0 project are isolated communities without current access to fresh water for drinking and for agriculture, and who currently rely on diesel-powered desalination systems. This project will allow isolated communities who currently do not have access to clean water or are reliant on diesel-generated desalination to access clean water in a sustainable manner using ocean waves. The funding from Marine Institute will help us develop our project towards commercialization and finalization of the technology's design.
The current project is Eureka Seawind, and the idea is to lower the centre of gravity of floating wind turbines. That in turn would reduce the cost of energy for everybody. The problem is the cost of energy, and specifically the cost of floating wind. So for floating wind, you have a very high centre of gravity for the turbine, and you have to build a massive substructure to capture the energy. By lowering the centre of gravity, you can reduce the size of the substructure. So that's the problem that it's solving, and ultimately it's reducing the cost of energy. In general, it benefits everybody, but more specifically, it reduces the cost of clean energy. I think everybody is aware of climate change, etc., and this is a part of the solution to that. Funding from the Marine Institute to Eureka Seawind is extremely important. The cost of entry to something like floating wind is massive, and in order to carry out the research, we would either need a huge commercial investor or research and development funding like that from the Marine Institute.